Hi, here's my presentation for Module 2. The question that we are asked is, what is the best land cover for a healthy watershed, and how do soil and land cover impact runoff and infiltration? I aligned this activity with two sets of standards, the first one being from the Pennsylvania Environment and Ecology Standards, and I think that it aligns with this standard because we're talking about watersheds and wetlands. Additionally, the next generation science standards align with this activity almost exactly. So these standards are a much better match than the first ones, but I did think the first ones went along with this as well. This is making observations or measurements to provide evidence of the effects of weathering or the rate of erosion by water, ice, wind, and vegetation. And that's basically what we're doing for this activity. Imagine, plan, and create. For this stage, I did use the model that was provided for us on D2L, but I kind of created my own picture. I also tried to brainstorm some possible solutions. To keep water runoff low, deep-rooted plants will help hold the soil, and I kind of learned that from the model, the watershed link that was provided for us on D2L. Also, large rocks mixed with smaller rocks can help filtration and clear water runoff. It can also help hold the soil, so the soil stays in place and only thing goes past is the soil or the water, excuse me. And then what are some natural filters? I tried to brainstorm that. So I started off by getting a Gatorade bottle, potting mix, and an X-Acto knife. I cut off the top of the Gatorade bottle, and then I added soil. And in one of my Gatorade bottles, I added soil and some seeds for grass and clovers. And then in another bottle, I added leaves, dry grass, mulch, and some pine needles. And here are my two side-by-side set up, ready for the experiment. So the first one that I tested was the one with mulch, grass, leaves, and pine needles. And here's a short video kind of showing what was happening. So as you can tell from the video, the majority of the water that came out was clear, and judging by the picture on the left, it was pretty successful at being clear water. Not something I would drink, but compared to my other bottle, this is a lot better. So here's my other bottle. This is the end product. The water is practically filled with soil. That's not even clear at all. And here's a short video of me pouring water into the bottle. So you can see right away compared to the other video, this erosion bottle came out with soil right away, where the other one, it kind of took a little bit and it was mixed in with a lot of water. Some STEM practices that I felt like this included were asking questions, carrying out an investigation, designing solutions, defying a problem, and then becoming aware of web technology. This one fell right under with the Model My Watershed activity, which was very beneficial to designing my erosion bottles. Some improvements for next time. First and foremost, I do teach a landforms and erosion unit in my classroom, so I think this will be a great activity that I'm going to have to add to have students explore in different ways. I was also curious with flooding versus regular rainfall. The way I poured the water in the bottle I felt was considered flooding it because it was a lot at once, so I would be curious to see how maybe sprinkling it or using a watering can would be different than just pouring it in from a cup. I was also curious to see if the size of the hole matters, so a Gatorade versus water bottle. I did use a Gatorade bottle, so I'm curious to see how a water bottle would work, and I would probably use it in the future. Additionally, if I would do this experiment in the future, I would add some wire or mesh covering to the mouth of the bottle to try to get rid of those bigger chunks of soil and grass that came through the hole. And then also I was curious about the amount of soil and the amount of watering to allow the grass to grow. I did feel like I saturated the soil in the can with the grass a lot because I was trying to get the grass to grow. So I didn't know if the saturated soil already played a part in holding the water. So if it was already full for me watering it, did it just deposit the leftover soil into the cup, and is that why it was so dirty? So those are some questions that I still have and improvements that I would try to reflect on in the future when I would do this activity again. Thank you.